team was tasked with creating a low-cost soiling sensor, and there are two big reasons why it's important to have one on the market. So first, to give a little context, soiling is the deposition of matter on the surface of solar panels in such a way that lowers the efficiency of energy production of those panels. So the two big motivations start with financial loss. So there's a huge financial loss associated with a decrease in efficiency of the solar panels. And the second motivation is it's important to have a low-cost sensor on the market. A higher-cost one already exists, but a low-cost one will make it more accessible to smaller research groups and also residential solar panel owners. So to reduce the effects of ambient light, our box only measures the efficiency of a solar panel at night. So how it determines whether or not it's night is through a simple photoresistor right here. So I'm going to cover it up so that the box will think that it's nighttime. Once it does that, it will bring a lever arm over and shine an LED light through the glass panel. We assume the glass panel will soil at the same rate as a solar panel because it will be sitting next to one in an actual solar farm. A more advanced photoresistor under the glass panel will measure the intensity of the light that comes through the glass panel and also determine the efficiency of the solar panels.
So I'll talk a little bit more about the actual design layout of the box. So we have our advanced photoresistor here, right next to the stepper motor, so that the stepper motor arm does not have to extend too far, so it's easier on the stepper motor and requires less power. The simple photoresistor is placed as far away from the LED as possible. The photoresistor's reading won't be reflected by the reading on the LED. And as for we drilled this hole here using a milling machine, and so that it's precisely the size of this glass panel that we intend to use to mimic the soiling on solar panels. And we also used the milling machine to drill a hole here that allows this integration of the stepper motor system that we will elaborate on later.
Our entire device is controlled by an Arduino. So first, the simple photoresistor detects whether it's daytime or nighttime. The Arduino takes in the values, and if the values being measured is below a certain value, it then tells the stepper motor via the stepper driver to rotate 90 degrees upwards and turn the LED inside. Then it programs to receive the values measured by this advanced photoresistor, which is then stored in this SD card. And if this photoresistor measures a value that's above the threshold, then it programs the stepper motor to turn downwards and to switch off the LED. We have two different batteries. We have a 1 9-volt battery for the Arduino and most of the other components, and 4 1.5 AA batteries for the stepper motor. We chose to have two different batteries as the stepper motor draws a lot of current, and connecting it to the Arduino could possibly damage the Arduino circuit, hence requiring more maintenance.
So here we have the arm that connects to the green LED to the stepper motor. The gray, green, blue, and red parts are all printed with 3D printing filament, and we chose to do this because it was light and pretty waterproof. And in the green part, we left a hole within the gray encasing so that the wires can pass through from the green LED all the way into our box.
After we finished developing our prototype, we tested it against our design criteria. The first criteria was cost. We wanted it to be under $500, and this ended up costing around $150, so it satisfied that criteria. Next, with consistency of data, we tested our device against some of our clients' known soil samples, and there was a constant correlation of as the soiling increased, the drop in light intensity increased. So there was a consistent result with that data. Next, with ease of maintenance, we believe that this device will have to be cleaned, and the LED will have to be cleaned each time you would clean the solar panels. So there will be no additional maintenance outside of the regular cleaning of the solar panels. Next, with accessibility of data, as JS mentioned, we used an SD card that displayed an error message when there was soiling. So the owner of the solar farm only has to retrieve the SD card to get all the necessary data about the soiling in their farm. However, in the future, we hope to integrate a Wi-Fi module so that data can be sent wirelessly to be even easier to access. And finally, with durability, we want to do additional testing with different weather-related factors. We used a weatherproof box, so we believe that it will be safe in many of the environmental conditions, but we believe further testing could be valuable. And finally, we hope to integrate other LEDs, such as infrared LEDs, and possibly further advanced photoresistors to continue to get consistent results and improved results. Thank you so much.